The focus of this lesson is on solving logarithmic equations. And the idea is if you can pull that equation down to a single logarithm, so either by using the properties and rules of logarithms to condense it or just already is, then what you would do is you would convert that equation to exponential form and then you would solve for your x. If you are unable to pull it down to one logarithm and you're left with maybe 2, or you could use your properties and rules to pull it down to 2, then you would go ahead and set one logarithm equal to the other, and if they have a like base, then by using the one-to-one property you would know that what you're taking the log of would be equivalent. And so you're going to use one of the two to help us solve our 3 examples. So we'll start off with our first example. It says log base 5 of x minus 2 is 3. Notice that is a single logarithm. So right at the start I can go ahead and start off by converting. So our base is 5 raised to the 3rd power equals x minus 2. So that's exponential form. 5 to the 3rd is 125 equals my x minus 2. Add 2 to both sides, we get 127 equals x. If we do check that, it does work out, so our solution is 127. In our next example, again you have a single logarithm, so you can go straight to converting. So you have your base a raised to the 0 power equals what you're taking the log of, which is x squared plus 5x plus 7. Use your property that a to the 0 is 1 equals x squared plus 5x plus 7, and then whenever you're solving a quadratic, pull all of your terms to one side, so subtract 1 off from both sides in this case, and you're left with x squared plus 5x. If you subtract 1 from 7, you're left with 6. That allows you to either factor or use the quadratic formula. In this case we could factor. What two numbers multiply together to give us 6 but add together to give us 5 would be 2 and 3. And so we set each of those factors equal to 0 and we solve. So we have x plus 2 equals 0 and x plus 3 equals 0. Subtract 2 from both sides, we get x is negative 2. Subtract 3 from both sides, we get x is negative 3. Check to make sure that those work out. And if we do check both of these, they do both work. What would cause not to work is if you plug them back in and what you're taking the log of is 0 or negative, you would have to throw those solutions out because the domain says that you have to be positive. And so if these values made your logarithm negative, you'd have to throw them out. In the next example, so let's do one more example, notice you have 3 logarithms. So this is one where we're going to want to use our properties and rules to help us condense. But notice each of these logarithms are the same base, 3. So that means we can probably use our properties and rules. So we have log base 3 of x plus 1 plus the log base 3 of 2x. Well, because those are the same base and it's a sum, we can rewrite that as a single log with the same base, but where we take the product. So x plus 1 times 2x equals log base 3 of 3x plus 1. And there's a couple ways to solve this problem, but we'll just keep it the way it is. And then we go log base 3. Go ahead and distribute that 2x. It would give us 2x squared plus 2x equals log base 3 of 3x plus 1. Again, by the one-to-one property, we now have log base 3 and log base 3. The only way those two logarithms are equivalent is if what you're taking the log of is equivalent. So we can go ahead and say 2x squared plus 2x would have to be equivalent to 3x plus 1. Again, you're dealing with a quadratic, so subtract your 3x from both sides, which will give you negative 1x, and subtract your 1 from both sides, will give you minus 1 equals 0. And then go ahead, if you can, and use factoring to help you solve. In this case, we would see that this does factor. It factors as 2x, and then we have x, gives us the first term, and then what two numbers multiply together to give us -1 or positive and -1. But put the -1 here and the +1 here, so that when we do the outside inside we get -1x. And then we take each of those and set them equal to 0 and solve. So 2x plus 1 equals 0 and x minus 1 equals 0. And this one, if we subtract 1 and divide by 2, we get x equals -1/2. If we add 1 to both sides, we get x equals 1. So our solution set is -1/2, 1. But we would have to check our solution. So it appears that -1/2 and 1 are our solutions, but we can't violate the domain of any of our original logarithms. So if either of these values make what's inside the parentheses, so what we're taking the log of, negative or 0, then we would have to throw it out from the solution set. So if we put -1/2 in for this first log, it looks okay, but in this second logarithm, 2 times a -1/2 gives us a -1, so it becomes log base 3 of -1. That's not okay because that's not part of the domain. You can't take the log of a negative value, so we would have to throw out the -1/2. If it doesn't work for one of the logarithms, it doesn't work for the entire equation. And then we would continue on and check for 1. If we put 1 in for the first logarithm, you get log base 3 of 2. That's fine. If you put it in for the second logarithm, you get log base 3 of 2. That's also fine because those are positive values. And then in the last logarithm, it becomes 3 times 1 plus 1, which is just 4, which again is positive, so that's okay. So your solution at the end of the day is actually just the set 1.